Today we're looking at assignment 5.3b, evaluating logs. Now we looked at the first page in the last video, so I'm not going to go over that again, but we're going to go ahead and look at this backside where it starts out by saying simplify each expression. Now I'm going to start by looking at problem 26. We'll go back to 25 in just a moment. But here on 26, notice the problem says log base 2 of 2 to the x, and you just want to simplify it and figure out what this equals. So remember how the answer to a log is the exponent. So this is going to equal something, we're not sure what, that's the exponent on our base of 2. So I'm going to think of this as 2 to the something equals this thing that's inside of our log, which is the 2 to the x power. So if you look at this, hopefully you'll notice that our bases here are the same. Well, if the bases are the same, then that means the exponent should be the same as well, which means that we would need to have an x inside this box. So that means that log base 2 of 2 to the x is going to be equal to x, which is our final answer here on 26. Now, keeping that in mind, let's now look at problem 25, where we have 8 to the log base 8 of x power. Now, in this case, I'm going to rewrite this in logarithmic form. So I'm going to think of this as log, and then my base, notice, is 8 of something, whatever it is that this happens to equal. Oh, sorry, there's no equal sign here. Okay, that's going to equal my exponent, which in this case, notice the exponent is the log base 8 of x. And again, if you look at this, hopefully you'll notice that we are looking at a log base 8 and a log base 8. Our logs are the same, which means that their insides should also match, which means that here in the box we're going to have an x. So that means that 8 to the log base 8 of x power is going to end up equaling x. Now, the pattern that I'm hoping you'll notice here is this. Notice how if my base and my exponent match, 8 and log base 8, they're going to cancel each other out and leave me with just the x. Same story here on 26. We had our log base 2 and our 2 that canceled each other out and left us with x. So if your bases match, then your log and your exponent will just cancel each other out. But look, for example, here at problem 27, where we have a log base 4 and then we have a 16. So here the bases do not match, but I know that 16 is the same thing as 4 to the second power. So instead of 16, I'm going to think of this problem as log base 4 of 4 to the second, and then we still have this x exponent that I need to include. So there's the x exponent. All right, well, remember how if you have 4 to a power, that's when you multiply the powers together. So this becomes the log base 4 of 4 to the 2 times x because the powers just multiplied. Well, now if you look at this, you'll notice that my log base 4 and my base of 4 now match, so they can cancel each other out, and we are left with just that exponent 2x, which is our final answer. So that hopefully explains this section right here. Go ahead and try finishing that section. But now we're going to go ahead and look at the very last section, which says find the inverse of each function. Now, hopefully you recall from our last unit that when we find an inverse, we begin by switching the x and y. So on 34, instead of thinking this as a y equals problem, I'm going to think of it as x equals the log base 3 of y. Well, now I would like to get the y alone, which means I'm going to have to rewrite this problem. If you remember back from the very beginning of this assignment, when we had, for example, problem 1, log base 4 of 1024 equals 5, we said that our base of 4 went to the 5th power because remember how the answer to a log is the exponent, so 5 was our power, and that equaled the 1024. Well, I'm going to use that same little rewriting trick right here where I say, all right, I can see that my base in this case is 3, so my base is going to be a 3. Now the log is equal to the exponent, so in this case it's going to equal that exponent of x, and that's going to equal the thing inside the log, which is a y. And y is now alone, which means this right here is my inverse. notice how finding the inverse is pretty much the same thing as the rewriting that we did back at the beginning of this assignment. So really fast, we're going to do just one more of these problems just so that you can see the process one more time. So I'm going to go ahead and look here at problem 39, where we have that y equals ln, or the natural log, of 6x. Now to start out, remember we switch the x and y, so this becomes x equals the ln of 6y. Now ln, remember, is, ln, remember, is a natural log, or in other words, a log whose base is e. Remember, we don't ever write log base e, but that is what it means. So that means that we are looking at a base of e. So if I want to rewrite this, I'm going to start with my base of e. Then remember how the log is equal to the exponent. So in this case, since my log is equal to x, I know that x is my exponent. And that's going to equal the piece that's inside the log, which is the 6y. So now my equation has been rewritten, but the y is not alone, and I do want it to be alone to finish my inverse. So notice how here I have 6 times y. To undo that multiplication, I'm going to divide on both sides by 6. So that's going to give me then that e to the x power divided by 6 is equal to y. Y is now alone, which means this answer right here is my inverse. So now that you've seen this process, you can go ahead and finish this assignment.